So dear students, welcome to my YouTube channel PCM Academy, and we are in lecture series of quantum mechanics. We have started the postulates of quantum mechanics, that is the most important part. And in the last class, I told you that why we need the postulates of quantum mechanics and what are the role of the postulates of quantum mechanics. Basically, it will give you the approach how to study the quantum system. And in classical system, we know the approach is same in classical system and quantum system, but as the inertia of the quantum particle is so low, so we will use different kind of mechanics with the different kinds of postulates, and this is a probabilistic approach, you can say. So we will discuss postulates one by one. So let me tell you about the first postulates. So let me write the first postulate first, then we will explain it. Okay, so what is the postulates 1? In classical mechanics, you know, you have to define the system at t is equal to 0, that is the statics of the system. What is the position and momentum of the particle, that is the state. If you talk about classical mechanics, the state means the initial position and momentum. But you know, in quantum mechanics, there is an uncertainty in position and momentum, so we can't define the system at t is equal to 0 in that way that we have discussed in, or we have defined in classical mechanics. Okay, so here what we have to do, we have to represent the system, the quantum system, by a state vector, or you can say a wave function psi. Okay, so the first postulate is that the state of any physical system, the state of any physical system at any time t, or at time t, is described by a state vector, or you can say a kate vector, or you can say a wave function. A wave function, simply psi function of t, or you can write in kate form, that is psi of t. This is kate vector, and what is the properties of this kate vector? We have discussed already the properties of Hilbert space. So if you are new in this channel, then go to the playlist and see one by one videos serially, so you can understand everything. Okay, so this is the first postulate, that we have to define the system at time t is equal to 0, that is the state vector psi of t, and obviously this wave function should be well behaved. So this wave function psi function of t should be a well behaved function, and what is the meaning of this well behaved function? That means that psi of t and its partial derivatives, that means del psi upon del t, or if you talk about the psi as a function of x and t, then obviously del psi del t and del psi del x, all partial derivatives of psi and psi the wave function itself should be single valued, okay, finite and continuous, okay. So this is the first postulate. And what is the second postulate? So let me tell you the second postulate also. So postulate number 2. Postulate 2. So what is the postulate 2 actually? So for any physical quantity, something like in classical mechanics, we have a lot of physical quantity, position, momentum, kinetic energy, potential energy. So these kinds of physical quantity here in quantum mechanics is known as observable, and this associated with each observable or the physical quantity, there is an Hermitian operator, linear Hermitian operator corresponding to this each and every physical quantity. We can corresponds to this each and every physical quantity operator, that is called observable, or you can say that is the Hermitian operator, which operate on the wave function psi and give you some value that is called eigenvalues, and the state vector under this operator is called the eigenvector, and the eigenvector under the Hermitian operator should be orthogonal, can be orthogonal actually. So we have discussed these kinds of mathematical things in mathematical tools. Here we will just state the postulates too. Okay, and the meaning of the each and every term of this postulates too we have discussed already in mathematical tools. So I am advising you that please go to the playlist and see the videos one by one, so that you can understand everything. So if you are a JAM aspirant, then you should be very clear about your concepts from very basic things, because this is not in your BSc syllabus actually, these kinds of mathematics. But when you talk about IIT JAM or JEST, that kind of exam, so you need to know about this Hilbert space or linear vector space, the properties of Hilbert space. That's why I discussed the mathematical tools also. But if you are a NET or GATE aspirant, if you are MSc students, then this thing will be little easy for you. But if you are a BSc students, then you should follow each and every lecture very your concentration should be very high, and you should learn the concept very carefully. Okay, so what is the postulate 2? Let me write it again, that to every observable means any physical quantity, to every observable or you can say physical quantity, that I have told you earlier, or you can say physical quantity. Suppose let me write it A. There corresponds a linear Hermitian operator whose eigenvector forms a complete basis. So you have to know about the Hermitian operator. So I have discussed lot of things about Hermitian operator. What is Hermitian operator in mathematical tools, and you have to know about what is the complete basis. Okay, so Hermitian operator, let me tell you again, the Hermitian operator means that actually A dagger, that is equal to A dagger means there is a transpose conjugate. If you have a course on matrix, then you know what is the transpose conjugate, and the transpose conjugate is equal to the operator itself. So this is called Hermitian operator, or in your matrix course you know this in terms of the Hermitian operator, the Hermitian matrix. Okay, and what is actually mean by complete basis? Complete basis means if there is different kinds of eigenvectors corresponding to eigenvalues, that is the phi 1, phi 2, suppose phi 1, phi 2, phi 3, suppose these are the eigenvectors corresponding to eigenvalues of a Hermitian operator, then if wave function psi can be written, the linear combination of this, that is psi 1 phi 1, c1 phi 1 plus c2 phi 2 plus c3 phi 3. If you can write psi, the state vector psi, with the eigenvectors by using this linear combination, if you can express psi in this kinds of linear combination, then you can say that this form a complete basis. So this is all about the postulates.